Hi everyone, this is your first video for this week on distance and midpoint on a coordinate plane. So in this video, I'm going to talk about and do some notes and examples for you on both the Pythagorean theorem, which I'm hoping that you remember from algebra, and then the actual distance formula. Just like all of my videos, I have what I would normally project for you up in the classroom on the left side of your screen, and some notes that you can use if you wish, note page that you can use if you wish on the right side of your screen. Like always, I am using Cami to take notes here, but if you would prefer to type in the documents in Canvas, you can do that. You can also just take notes in a notebook if you prefer, if that works better for you. It's completely up to you how you want to do this. All right, so let's jump into it. So before we can talk about the distance formula, we have to understand the Pythagorean theorem. Okay, and the reason for that is because the distance formula is built on the Pythagorean theorem. Okay, the distance formula is just the Pythagorean theorem converted to use coordinate points instead of lengths, like side lengths of a right triangle. So I'm hoping that you remember what the Pythagorean theorem is from your Algebra 1 class. But if you don't, or you may not remember exactly what it's called, but you probably remember the formula. Okay, so the formula is a squared plus b squared equals c squared. Okay, c is always the hypotenuse, so it has a very fanciful special name. Okay, it's always the longest leg, and it's always across from the right angle. Okay, and then your other two sides are called legs because we're dealing with a right triangle, so they get special names. Okay, it does not matter which leg you call A and which leg you call B. That does not matter in the context of the problem. So if you look on the left side of your screen, there's an example here with this triangle here. So you have one leg that's 6, one leg that is 8, and then your hypotenuse is x. Okay, so if we were to label this, let me change my pen color here so we can see this a little better. If we were to label this, I would call x is C. Then I would call one of my legs A and the other leg B. Like I said, it really doesn't matter. Typically, we choose the smallest leg for A and the next smallest for B, but you could switch them. It doesn't really matter. So what we're going to do is we're going to plug these values into the Pythagorean theorem. So wherever you see an A, plug in a 6. Wherever you see a B, we're going to plug in 8. And wherever you see a C, you're going to plug in X. Okay, so that's exactly what I did here when I worked this out. Okay, so here I did a squared, so 6 squared plus b squared, turn this on so we can see this, equals x squared. Okay, remember 6 squared is not 6 times 2, it's 6 times 6. So you have 36 plus 8 squared is 64 equals x squared. Then I need to combine my like terms, so I get 100. Okay, and then to cancel out a squared, right, so that's this exponent right here. To cancel that out, we have to take the square root of both sides. Okay, so x is the square root of 100, which is technically positive or negative 10. But remember, side length, distance can't be negative, right? Those two things, that can't be negative. So I'm drawing for you here. This is what's actually happening when you take a square root. It's canceling out that squared. Just like when you cancel something out that's being added, you subtract it. Something that's being multiplied, you divide it to cancel it out. Okay. So remember, when you take the square root of something, when we're in geometry, for the most part, those are always going to be positive because we're usually talking about side lengths or distances or something, which, if you remember from last week, those always have to be positive. Okay. All right. So let's do, let me switch over here. Let's do, maybe this is going to cooperate with me here. All right. So let's do some Pythagorean theorem examples. okay? And I'm going to do them over on the right side of your screen. So I'm going to change this a little bit, make this part a little bit bigger so that we can see this. All right, so I'm going to do two examples for you here. All right, so I gave you here in the first example that A is equal to 4 and B is equal to 7, and I want to know what C is. C is what I don't know. So I'm going to plug those values into my formula, which is A squared plus B squared equals C squared. So this is 4 squared plus 7 squared equals, and C is what I don't know, so you can just leave it as C, or you could put an X there if you wanted. Either way, doesn't really matter. Okay, 4 squared is 16. Okay, so 16 plus 7 squared is 49 equals C squared. Okay, then I need to add those two things together. So when I do, I get 65 here on this side. Okay, now if you remember your perfect square numbers, okay, if you remember your perfect square numbers, so that's like 4 squared is 16, then 5 squared is 25, 36, 49, 64, right? This right here, 65, is not a perfect square number. So when we take the square root of this, boom, just like this, you're going to end up with a decimal value. Okay, and that's fine. You're supposed to end up with a decimal value. If you were in one of my honors classes, then I would recommend that you review how to simplify radicals, because sometimes questions on like IB and AP and like those tests that we have to give you for the programs that you're in deal more with simplifying radicals and not as much with decimals. Okay, but for the sake of this video, what I'm going to do is I'm just going to take the square root of 65 and I'm going to get a decimal. So when I do, I get 8.06 equals C. Okay, all right, and that's it. So my answer here is 8.06. It's going to give you a lot more decimal places than that, but 2 decimal places is usually fine. Especially for me, when you're doing problems for me, that's fine. 2 decimal places is fine. All right, let's do a slightly different example here where I gave you A and C, and I want to know what B is this time. So I still have A squared, so 8 squared, plus, I don't know what B is, so I'm going to put B squared right here, equals 17 squared. Okay, all right, so I need to go through and square the numbers that I have. So 8 squared is 64, so you have 64 plus B squared equals, and then 17 squared is 289. Okay, so now my next step, because the goal is to get this by itself, right? That's the goal. I want to get that by itself. So I'm going to subtract 64 from both sides. Minus 64. Okay, so you have B squared is equal to, and then 289 minus 64 is 225. And then my last step always, whenever you have something that looks like this, something squared equals a number, the very last step is always take the square root, because you want to cancel out that exponent. So you get that B is equal to 15. 225 is a perfect square number. Okay, so you get 15. So this combination of numbers up here at the top, 8, 15, and 17, that's an example of something called a Pythagorean triple, which is a very fancy word for 3 numbers that are whole numbers, that when you put them into the Pythagorean theorem, that they work out. All right. Okay, so those are your Pythagorean theorem examples. Okay, so next, let's connect this idea to the distance formula. Okay. Oops, sorry, this is refusing to cooperate. Whoops, there we go. Okay, so let's build the distance formula. Okay, so if you look on the left side of your screen here, we have a couple of things. So if you are trying to find the distance between two coordinate points, right? These are my two coordinate points, x1, y1, and x2, y2. Okay, I put a little note for you here that the small number is just a label. Okay, so it's a subscript, right? It's just a label. So you don't do anything with those. You don't add them, multiply by them. It's not like an exponent. It's just a label. Okay, so x1 is the x coordinate of point number 1. It just helps us to distinguish between our x values and our y values. Okay, so originally what I'm trying to do here is find this distance. I want the distance from this point to this point. Okay, that's what I'm trying to find. So if you were to do this step by step, the easiest way would be to draw a right triangle in, okay? And then what we want to do is figure out, I have a missing coordinate point, which is this guy right here, okay? So I have to figure out what is that coordinate point, okay? Well, what I can do here is say, well, okay, this point here has the same x coordinate as this point up here because they're right underneath each other, right? So this x2 goes right here, okay? And then we're going to do a similar thing for the y's. Say, well, this guy has the same y value. See here, y has the same y value as this point right here because they're right next to each other, right? The new point that I drew in hasn't gone up or down at all. It's literally exactly to the right of my x1, y1 point. So this has the point y1, okay? So here, if we wanted to use the Pythagorean theorem, right, because you have a right triangle, so the best way to find side lengths as of right now in a right triangle is to use the Pythagorean theorem, right? A squared, b squared, and c squared, right? So on here, I have that what I'm actually trying to find is c right here, because that's the hypotenuse of the right triangle, and then you have a and b right here, okay? But then we have to figure out, they didn't give us any numbers, so how do we figure out how long this is, right? But remember, this is just distance like of a straight line, almost like distance on a number line, which is what we did last week, okay? So the distance on a number line is just, I'm going to take my taller point, this one, and subtract it from my smaller point. Those are my two endpoints, right? So it's like y2 minus y1. And we're going to do something really similar for A, where we can take, let me change my color here, where this pink guy down here is like a number line. So I'm just going to subtract my two endpoints, x2 and x1. Okay? All right? So now, instead of saying a squared, we would say x2, whoops, hold on, put my 2 in the wrong spot, x2 minus x1 squared, right? And we can do a similar thing for b, okay? The reason I'm showing you all of this, which is because it probably looks a little crazy right now, but the reason I'm showing you this is because this is how the distance formula was built. It's basically just the Pythagorean theorem, but it looks more expanded and a little bit more complicated, okay? So instead of using A, B, and C, we're going to use these distances, right? Because that's all we have. We don't have the lengths of the sides, we have the coordinate points, okay? So when you actually look at all of this, and I'm going to clear my screen, when we put all of this together, the actual distance formula looks like this, okay? So the actual distance formula is this right here. It's this very long and kind of complicated looking formula, okay? but it's based on the Pythagorean theorem, okay? So when you have the regular Pythagorean theorem, a squared plus b squared equals c squared, and I'm going to write it backwards just so that it matches. What we are always trying to find is c, like that's our distance, okay? So rather than writing the c with a squared, if I take the square root of both sides, I can get rid of this squared right here, okay? Because this is what we're looking for. The end goal is to find c in the Pythagorean theorem. That's what we're doing. Okay, so like I said on the last slide, rather than saying this distance right here is a, because I don't know exactly what it is, instead of that, it's the horizontal change. Right? Instead of B for the vertical leg, because I don't know exactly how long it is. They don't tell us that. They only tell us the coordinate points. Instead of B, we're going to say that's the difference between the two y endpoints. Okay? Now, here's the thing. And while I'm talking about this, I'm going to write it for you on your notes side. Okay, I'm going to write the actual formula. Okay? If you're looking at this and you're like, Miss E, this is a crazy long formula. And you're right. You're not wrong about that. It is kind of a crazy, complicated, and long formula, okay? But the actual problems that you do with the distance formula are not super complicated because they're going to give you the 2 points that you need. So you just have to plug the numbers into the right place and then follow your order of operations, right? So when you're doing this, the steps here are plug in the points and then follow PEMDAS. Okay, that's what you're doing. Those are the steps when you're doing the distance formula. Okay, and I'm going to show you what I mean here. Okay, so I'm going to pull this over. Whoop, and we're going to go through the steps here. Okay, so we're going to use these 2 examples right here, and we are going to go through the steps. Okay, so step number 1 is to pick one point that they give you to be 0.1 and the other point to be 0.2. It does not matter which one you choose. It does not matter because they're both technically endpoints, right? So same as last week. It doesn't matter which one you choose to be 0.1 and which one you choose to be 0.2. That worked on the number line. So it's the same thing here when we're talking about distance on a coordinate plane, okay? So here, typically, I read from left to right. So typically, I call the first point I see point number 1, and the second point I see point number 2. Okay, so that means, let me zoom in on this just a little so we can see this a little bit better. Okay, so that means that this -3 is x1 and 14 is y1. Okay, and then for R, 7 is x2 and 5 is y2. All right, so now we're going to plug those values into the distance formula. So you have D equals, and here's my whole formula, x2 minus x1 squared, so always keep your x's together, plus y2 minus y1 squared, and always keep your y's together. All you have to change is the information, the number that goes here, 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 and here. Everything else stays the same. The square root, the minus sign right here, these squares, this plus sign, it all stays the same. All right, so I'm going to take my values and plug them in. So x2 goes right here, and x1 goes right here. And then, so let's write that out. Let me change my pen color. Okay, so you have D equals the square root of x2 is 7. So 7 minus and then x1 is -3. Notice that I'm writing both minus signs in there. The reason I'm doing that is so that I don't accidentally drop a negative sign, okay? So it's minus -3, okay, plus, and then I have my y's. So y1 goes right here, and y2 goes right here, okay? So I have plus, y2 is 5, minus, and then y1 is 14. And I have my squared here at the end, right? So that's step 1. Take the information, or label your points. Step 2, take your information and plug the numbers into the distance formula. So now, after this, I need to simplify using PEMDAS. That's your next, or really your last step. So I need to simplify what's inside my parentheses first, right? Because that's the first order, that's first in the order of operations. So you have 7 minus -3. When you have 2 minus signs right next to each other like this, those both become plus signs. So this turns into 7 plus 3, which is 10. Okay, so I have 10 squared plus 5 minus 14 is -9. Oops, sorry guys, that 9 looks crazy. Let's try that again. Okay, so 5 minus 14 is -9 squared. Right, so that's P in PEMDAS. Okay, next I need to do my exponents. Okay, so 10 squared is 100 plus, and -9 squared is 81. So that's E in PEMDAS. Okay, there's no multiplication or division. There's no multiplication or division. So now I need to do my addition. So 100 plus 81 is 181, right? And then after that, your very last step, so that's my addition, subtraction. Oops, hold on. Forgot my S right there. Okay, it'll always be addition at the end, right? But I'm just kind of showing you how this follows your order of operations, PEMDAS. Okay, your very last step is always, 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 always to take the square root of your number inside the square root. So in this case, I'm doing the square root of 181, okay? And I get 13.45 when I do that. Okay, so that is my final answer. All right? Okay. So let's do one more example. If you want to pause the video and try this example on your own, you can and come back and check. But if you want to keep going with me and kind of watch me explain it, then you can definitely do that. Okay, so let's go ahead and take a look at the second one here. So step number 1, label points as point number 1 and point number 2. There you go, 1 and 2. So 4 is x1, 11 is y1, -11 is x2, and -5 is y2. All right, so let's plug those values into the distance formula. Okay, so D is the square root of x2, which is -11, minus x1 is 4, squared, plus y2 is -5, minus y1 is 11. Extend my square root a little bit. All right, so I've plugged my values into the formula. Next, I need to simplify what's inside my parentheses. So -11 minus 4, they have the same sign. So the rule is when they have the same sign, you add the numbers and keep the sign. So this is -15 squared plus, and then same thing over here for y. You have -5 minus 11. They have the same sign, so you add the numbers and keep the sign. So this is -16 squared. Then I need to square those two numbers. Okay, remember whenever you square a negative number, it becomes a positive number, always, always, always. Okay, so negative 15 squared is 225 plus negative 16 squared is 256. Okay, so then I need to add those together. So I get D equals the square root of 481. Okay, and then I need to plug that into my calculator and take the square root of 481, and I get 21.93. Okay, 21.93. All right, so that is it for the distance formula, guys. All right, so in the next video, I'm going to do some practice problems for you. Some of them will look like this, where it's just some straight plug in the numbers and simplify in the distance formula. Some may have pictures on them, and some we're going to have to, I think there's one on there where we're going to do just a little bit of solving. All right, so I will see you all in the next video. Bye, everybody.